SOA University, a place which is very close to my heart because I was privileged, as you have just mentioned, 3 years back when the DSc degree honoris causa was conferred upon me by your esteemed university. So it's a privilege for me again and a prestige and honor for me to deliver the 40th oration which you have so kindly invited me for. I'll be talking about the subject area of which I'm still a student. I consider myself a student. And that subject is astronomy and astrophysics. So I'll be delivering this lecture with the help of a PowerPoint presentation. So if you'll allow me, I will just take some 10 seconds to present my screen for the PowerPoint presentation. So can you kindly see tell me you can see the slide?
Yes, sir, it's visible to us.
Okay. The topic of my lecture today is the final frontier. By the word final frontier, I wanted to mention that the human mind has, from the thousands of years back till today, have desperately tried to unearth, to understand nature in its fullest, in the grandest scale as well as in the microscopic scale. And in this understanding, ultimately we have realized the very basic questions about nature, what we call science. That question, the answer probably will be answered by the deep cosmos that we are seeing around and progressively going deeper and deeper. So that is the reason I consider the cosmos as the final frontier of human knowledge, of human understanding, and the endeavor of the human civilization to understand everything around us. But before I start my lecture, for the last 2 months, the internet, social media, everywhere, we are getting bombarded by fantastic images of the cosmos taken by an instrument which is called James Webb Space Telescope. So I will begin with the ending in the sense that whatever is our ultimate understanding of recent times, an object, a spacecraft which is sent on the month of December, 25th December, went in its parking place in February. From June onwards, it has started giving us fantastic pictures of the farthest end of the cosmos, of the oldest subject, as well as of objects nearby, of nebulae, star clusters, even our solar system objects, Jupiter or Neptune with its rings, or even Mars. So that tells us that whatever we have known of these cosmic objects, there is much to know about it. And not even in our galaxy or neighborhood, even in other galaxies like Tarantula Nebula or the Cartwheel galaxy with its peculiar shape and size, a cluster of galaxies together, or even something which was only theoretical some years back, now observed called Einstein ring. And ultimately it has found planets going around different stars and trying to find out whether they are habitable or not. So, starting looking from our Earth, the times are very exciting. So let me go back to thousands of years back when our ancestors used to look into the sky and wonder, what is sky? Where is sky? What are those objects that we call star? And is there any connection between the stars and the Earth? With these set of questions and queries, the subject of astronomy was born. So astronomy can be considered as one of the oldest subjects that human minds have dwelt upon. At the same time, given the huge number of news items that you regularly get to see in television channels and newspaper, you get an idea that it is also the most contemporary subject of importance in the scientific community. Astronomy is a subject which can tell us what was the physical situation in a particular area on Earth millions of years back. At the same time, it can tell us what can be the situation possibly billions of years later at the same place. So it deals with a vast expanse of not only space but time as well. And it has the potential of unfurling the mysteries of universal nature. Just to tell you the importance of this subject, starting from 1901 till 2000, in 100 years, only 3.5 Nobel Prizes were given in astronomy, astrophysics, cosmology, and general theory of relativity. Whereas, starting from 2000 to 2022, 6 Nobel Prizes, 17 Nobel laureates were awarded the Nobel Prize for research in these subjects areas of astronomy, astrophysics, cosmology, and general theory. If you have a question that which are the subject that wants to study, and there is an amazing answer to that, any branch of science, physics, chemistry, mathematics, biology, statistics, engineering, computer science, whatever field of study you can have, in your later period of your life, you can meaningfully contribute to the academics and research of astronomy and astrophysics. And that is probably the reason for the last 20-30 years, as if a revolution has happened. Every country, developing, fully developed, underdeveloped, they're desperately trying to build newer and newer facilities, bigger and bigger telescope. For example, see this. In the coldest desert on the earth, in the Atacama Desert, they have built this fantastic, very large telescope, a complex of 4 optical telescopes at a place called La Paranal, Chile. And this is one of the finest technological marvel that the human mind have created. Hawaiian archipelago, small island called Mauna Kea. On top of Mauna Kea, at the height of 14,000 feet, 15 countries have built 12 telescopes. The smallest one cost is around $500 billion. But you should be happy as an Indian. The largest telescope is not yet built. The work has started in 2018. Probably it is going to finish by 2025 or 26. The world's largest telescope will be called the TMT, 30-meter telescope. A telescope with a 30-meter diameter mirror at the heart of it. The cost of building this telescope is so large, not a single country is building it. America, China, Japan, Canada, and India. In 2018, the then Prime Minister declared in the Lok Sabha that the India's contribution for building this telescope will be around 1,400 crore rupees. Just believe, for one instrument, that is the India's contribution. And not only in optical light, in radio, because the radio waves can penetrate the atmosphere like the optical light. You can see the universe in radio from the Earth itself. And one of the largest radio telescope system is in India. Giant meter wave radio telescope around 90 kilometers from Pune. 30 steerable dish, each of 45-meter diameter, presenting an effective reflecting surface for the incoming radio waves of 25 square kilometers. And in 1915, Albert Einstein gave his general theory of relativity. And out of those understanding came the concept of space-time and what is the new definition of gravity. According to the theory, gravity is not just an attractive force. If you consider the space and time as a stretched membrane, and if you put two objects, a small one, then there will be a curvature created at this position, and a bigger one, a bigger curvature. And between the small and the big body, there will be a curve. And as a result, the small body cannot stay still, cannot be at rest, and will ultimately touch the bigger body. That is gravity. So gravity is not a force of attraction, rather the nature of the curvature of space-time telling other bodies how to move in those curvature. So in this concept of general theory of relativity and gravitation, if you now consider a stretched membrane and two very small but very compact, very heavy objects going round each other, then there will be a ripple that will be created on the space-time called gravitational radiation or gravity waves. And in 2015-16, these gravity waves were detected by two fantastic laboratories in US called LIGO, Laser Interferometric Gravitational Observatory. And as an Indian, you will be very happy to know that one of the first international associate for the LIGO project is India. In the state of Maharashtra, they have started building the Indigo project, which will be one of the supporting laboratories of this LIGO project that is going to take the world by the storm. Night sky. Thousands of years back, our ancestors used to look into the night sky and used to wonder what is the meaning behind those lighted dots, but they could find an answer. In the desperation, what they did, they chose different parts of the sky identified closely spaced stars, joined those stars through straight lines, and created imaginary figures. In this way, the whole sky was divided into 88 regions, each region being governed by an imaginary figure, which we today call constellations or taramandal. You may be asking that these are all imaginary. Why should today's generation know about their names or their relative position? If you ask me, even today they have not lost their physical relevance. Just to give you an example, suppose a batch of you has gone for a hitchhiking trip, night has happened, moon is not there in the sky. You have lost your way. And suppose somebody in the morning told you that if you go in the northern direction, there is a locality. But which is the northern direction? If you happen to see the Saptarshi Mandal, dig deeper as it is called in the Western parlance, take the last two stars, join them in your mind, produce it out of the sky. It will heat up on a single star, and that star is the pole star. The moment you get to know the pole star, you know which is north, south, east, and west. So even today, these sort of imaginary signs and signatures have not lost their physical relevance. Let us not talk about the sun, earth, and the moon. You may be wondering that these are taught at the LKG nowadays. What is big news about it? See, I have seen enough number of teachers getting a little flustered when a small boy or a girl asks them, that, can you tell me what is the speed of the earth around the sun? It's a simple question. 29.5 kilometers per second. Imagine a car in 1 second moving 30 kilometers. But we are forgetting. We will say that that is not possible. 1 second, 30 kilometers, not possible. But we are forgetting that you, me, 780 crore people, millions of other forms of life existing on the surface of the earth, every point of their existence, they are moving at a velocity of 30 kilometers per second. Though you are thinking that you are sitting tight at this moment, I am also sitting tight at my position. One thing I also wanted to impress upon you, which astronomy and astrophysics have made us realize, that we exist on Earth, that we continue to live on Earth, is a result of a series of chance happening. Our existence can be best termed as an accidental existence. Though in our real life, we think each one of us individually are so powerful, either muscle or intelligence or money or political patronage, whatever. But we forget we are here, we do exist, we do continue living because of some series of chance happenings or series of accidental happenings that has occurred on Earth. For example, change of seasons. We all know Earth is going round the sun around an axis, and it goes round itself once in 24 hours around another axis, and these two axes are not parallel. They are inclined at an angle of 23.5 degrees. And it is because of this tilt of 23.5 degrees of the spinning axis compared to the revolution axis, season changes occur. Because at one point, sunlight falls directly onto the northern hemisphere. The sunlight falling directly will be absorbed and re-radiated, and range will have a certain amount of energy re-radiated in space. At the same time, if the same beam of light falls slantingly on the southern hemisphere, because it is slant light, more area, so the average energy power unit area which will be absorbed and radiated will be smaller than the northern hemisphere. And that is the reason it will be summer in the north, winter in the south. 6 months later, it is just the opposite. Now sunlight is falling directly onto the south. It is summer in the south and winter in the north. And this is the reason season changes occur. But why season changes are important? Because, my friends, if there were no change of seasons, there would have been no ocean currents. If there are no ocean currents, there would have been no air currents in our atmosphere. And if there are no air currents in our atmosphere, clouds would not have born somewhere and gathered somewhere else and gave us rain and fresh water. Life would not have been possible because just after Earth was born, it would have been a barren desert. So you and me exist. This is because of this accidental tilt of 23.5 degrees. Solar eclipse, we all know, though there are a lot of taboos, a lot of misbeliefs about solar eclipse and its effect on human being, but in 21st century, we know that this is just a natural phenomenon. One side is the sun, middle is the moon, one side is the earth. Sun's rays falling onto the moon, moon's shadow falling into a small patch of space, and people staying on that patch of space at that point of time will see as if the sun has vanished. This produces one of the most beautiful picture in nature, a total solar eclipse. It's going to happen in this picture. It was during a total solar eclipse, sun was discovered as a new avatar. They found out from the surface of the sun, milky white radiation is coming out which cannot be seen on other times. When they asked themselves a question, they were amazed with the answer. They found out from the surface of the sun every second, on an average, 16 lakh tons, 1.6 million tons of charged particles are coming out. These charged particles, as they move through the magnetic field of the sun, they produce this milky white radiation. The average velocity of these charged particles are 450 kilometers per second. At that speed, they have enough momentum. If they hit any atom or molecule, instantaneously they will break apart, evaporate. That means if I stop now and go and stand on the sun, the charged particle coming out of the sun, the moment they hit my body, within fraction of a second, my whole body should disintegrate. But I'm alive. How? I will come to that. Tides, another very interesting phenomena, because in our childhood we have all learned life first occurred on ocean. How did it come onto the land? It was this high tide every day. There's to wash ashore multicellular organisms. There's water is to go down, there's to get stranded and killed. But over millions of years, they got the adaptation of staying alive on land, and from there, different organisms, different animals, mammals, reptiles occurred, monkeys occurred, and from monkeys we have arrived. So that we are here is because tides are there. If I now ask you, sorry, if I now ask you, why does tide occur? I think everybody knows the answer. And the most common answer is, it is moon which is attracting the water on the earth, causing the water to heat up, rise, and tides occur. But my friend, class 11, sorry, is there any comment or something? I can hear some voices. Please let me know. Is there any problem?
No, sir. There's no problem. I would request everybody to mute themselves.
Okay. Oh, sorry. Okay. But if you remember your class 11 days, Newton's laws of universal gravitation, G m1 m2 by r square. If you use the formula and do a calculation, you can show sun is attracting Earth 173 times more than the moon does. Then why do you say it is tide occurring because of the moon's attraction? Because, my friend, tide is not a force. It is rather the resultant of quite a number of force over unit distance, or what is known as force derivative, m1 m2 by r cube. And that is the reason, since moon is still at 84,000 kilometers away and sun is 15 crore kilometers away, moon wins. But a lot of our teachers never tell us that sun also attracts the water on the earth. Do you know how much? 47% than the moon does. Not a small amount. Moon. What is moon? This picture is a beautiful picture taken from the surface, near the surface of the moon, Earth arising from the horizon of the moon. According to 99% of the scientists, 452 crore years back, or 4.52 billion years back, a huge ball of rock came and slammed onto the earth. With such a force, huge amount of surface material got gouged up and was thrown up into space. It couldn't go away forever, but going to a very vast distance for millions of years, it condensed, coagulated, coalesced, and has given birth to our moon. This theory goes by the name the collision ejection theory. And two things happen after that collision. Earth forever was tilted by 23.5 degrees and started spinning, and the Pacific Ocean, the present Pacific Ocean, was formed. It is now our time to start our journey in space and time. Why space and time? Because we know light has a velocity, 3 lakh kilometers per second. We also know in class 7-8 textbook is written, the distance from sun to earth is 8.3 light minutes. That means when tomorrow you see the sun, for a fraction of a second, you have to tell yourself the sun that you are seeing is an image of the sun as it was 8.3 minutes back. The closest star, Proxima Centauri, 4.2 light years away. Today evening, if you see the star, you have to tell yourself, the star I am seeing, it is the image of the star as 4.2 years back. So my friend, next time, younger kids at your locality or your house tells you to take them to the science city and spend 50 rupees on a time machine ride, don't. Any clear night, go out into the open, tilt your head. As you are looking deeper, you are looking at your own past. We don't realize that we do an instantaneous time travel the moment we look up in the sky. It's a fantastic feeling. The first stoppage of our journey is the solar system. These are all the real pictures of the main avatars of the solar system: Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Poor Pluto has been kicked out. Sun is a ball of gas. Tell me, my friend, if I take a football, pump in a lot of colored gas, cut open the football, will the gas inside remain like a ball? It will diffuse out. Then how come Sun, being a ball of gas, is not diffusing out into the sky? According to the scientists, 4.6 billion years back, a huge cloud of gas and dust was floating in space. This cloud was made up of 91% hydrogen, 8% helium, 1% rest other elements. The average temperature of this gas cloud was minus 240 degrees centigrade. At minus 240 degrees centigrade, out of the four fundamental forces of nature, only one type of force comes into play, and that is the force of self-gravity. The force of self-gravity will attract the periphery of this gas cloud towards the center. As the gas goes toward the central density builds up. As the density goes up, pressure builds up, temperature builds up. And starting from minus 240 degrees centigrade, the temperature rose to a fascinating level of 1.5 crore degrees centigrade. And at that temperature, four hydrogen nuclei, basically protons, they as if they come together, fuse together, and produce a helium nucleus. This hydrogen to helium transformation, the thermonuclear fusion reaction, our scientists have been able to perform it in the labs, but most of the time cannot control it and use it to explode a hydrogen bomb. But inside the sun, when in a very regulated manner, four hydrogen goes on to give rise to a helium, huge amount of energy is produced. As the energy tries to come out, it produces a back pressure called radiation pressure. And this radiation pressure, when it exactly balances and matches the inward force of gravity, sun being a ball of gas, remains hanging there for billions of years. It's an amazing thing. That we're alive, that life occurred, that Earth is like what you see today, because 15 crore kilometers away in a ball of gas, two opposite forces are continuously cancelling each other every second of our existence. Don't you think it's a chance happening? And these two forces cancelling each other, in technical terms, is called conditions of hydrostatic equilibrium. Sun has three zones at the center, in the inside. At the very center where the thermonuclear fusion reaction is going on is called the core. Then the energy that is produced for a huge volume, it freely flows, called the radiative zone. And then sun is very funny looking. From the surface up to a depth of 650 to 700 kilometers, pillars of gas, columns of gas stacked one after another. Heat comes from inside, hits the bottom layer. Gas, when it's heated, rises up, comes to the surface, deposits the heat as sunlight, and becoming cold like a fountain, it goes down and continuously raises the heat from inside. This is called the convective zone. Outwardly, sun is again divided into three parts. The sun that you get to see in the early morning or late evening is called the photosphere, sphere of light. Over photosphere, in a very thin layer, exquisitely pink colored gas can be seen, spikes of gas called chromosphere. Chroma means color. And for thousands of kilometers, a milky white radiation coming out from the surface of the sun called corona. The word corona comes from Latin. It means crown, as if sun is wearing a crown. This picture is actually the true picture of the surface of the sun. It has this very scratchy mottled surface. If you look properly, it is this beehive-like structure. Each is a column of gas. As the heat is coming through the middle of the column, it is lighted. The moment it comes on the surface, deposits the heat as sunlight, becoming cold, going down. Since the heat is missing, it is typically dark in color. The average size of each of these cells is 950 to 1,000 kilometers on the surface of the sun. And this picture gives you the beautiful picture of chromosphere, taken mostly during a total solar eclipse. When the disk of the lighted sun is covered by the moon, you get to see these spikes of red-colored gas called chromosphere. And one of the most beautiful picture of nature, corona, solar corona, milky white radiation coming out from the surface of the sun. Sun sometimes become very active. You get to see black splotches, kale dhabbas on the surface of the sun. Sometimes one, sometimes 10, 20 in a group. They are called sunspot. What are they? The surface temperature of sun is 5,600 degrees centigrade. At that temperature, gas cannot remain as gas, it becomes what is known as plasma. Plasma has a property. Wherever there is a magnetic field, plasma will try to get deflected from it. On the surface of the sun, very randomly small pockets of magnetism to form. A column of plasma trying to bring the heat from inside. If it realizes that there is a magnetic field, it will not come out straight. To take the heat away from different directions, no heat comes from that region, so it is typically dark in color. If you want to see the actual image of the sun, this is the image of the sun. It has taken around $1.2 billion to get this photograph by Solar Dynamical Observatory satellite sent by NASA in 2012. Sun is not very smooth as we see in the early morning or late evening. Tremendous number of explosions are happening every moment. Thousands of tons of gas are getting thrown out from the surface, reaching a height of 10 to 25,000 kilometers, again falling back onto the surface, making beautiful arch and loops. Sometimes they get thrown out with such a force, they get detached from the surface of the sun and move around the solar system like a solar wind or solar storm. If you don't believe me, 2015 this photograph was taken. See this beautiful arch. Do you know what is the size of this cavity of this arch? Three Earth, three Earth can go side by side inside this cavity, and that tells you the enormous size, activities, the energy, everything about sun. This is an X-ray picture telling you how tremendously charged and energized charged particles are coming out. And if what I told you, if they fall on me, you, any building, anything on Earth, instantaneously, poof, vaporized. Why we are alive? Again, you come to know we are alive by a series of chance accidents. By accident, Earth behaves like a bar magnet. Around the Earth, like a peels of an orange, there's an invisible magnetic shield. The charged particle, they come and slam onto the magnetic shield, cannot enter, flow past the Earth, and we think we are the king and queen of ourselves. Amazing. But in the northern and southern magnetic polar region, there is as if a gap, open field lines. So through these open field lines, the charged particles do enter the Earth's atmosphere before hitting the ground and destroying everything. They interact with the air molecules and make them glow. And what we get to see? Aurorae. Aurora borealis in north, Aurora australis in south. So in addition to the wonder, amazing scenery of an aurora, it also reminds us that sun is intimately interacting with Earth every second of our existence. A little bit this way, that way now. Just raise your hand and wait for things to happen. So the solar system, how did it happen? It was a spherical ball of gas and dust. Because of self-gravity, it was becoming smaller ball, but it had a spin. Because of the presence of the spin, a bigger ball will never become a smaller ball. Because of conservation of angular momentum, it will condense into a disk. At the central part of the disk, when the temperature was 1.5 crore, sun was born, and at the outer periphery, where the temperature was less, gas and dust condensed, coagulated, coalesced, and gave birth to our planetary system. So this may have been the picture at the early times of the solar system. As the sun was getting born at the center of this gaseous disk or the dust disk, in the outer periphery, gas and dust condensed, coagulated, gave birth to very hot spherical objects. For millions of years, they dissipated away the heat, and at least the first four, Mercury, Venus, Earth, and Mars, became rocky, terrestrial, solid, whereas the outer four planets, Jupiter, Saturn, Uranus, and Neptune, are mostly made up of gas. This is a collage of all true color pictures of planet. Mercury, Venus. You do not get to see the surface of Venus covered by a thick layer of cloud. The cloud is made up of concentrated sulfuric acid vapor. The average atmosphere has 95% carbon dioxide. As a result, the greenhouse effect is so critical. It being the second planet, it's still the hottest planet of the solar system. Next is our mother Earth. Let us not talk about her tonight. Next is the red planet Mars. Why red? Because it is rusting on the surface. Ferrous and ferric oxide mostly covers the surface. But this 2002 photograph taken by Hubble Space Telescope has energized the scientists, because in this photograph you can see Mars rusting on the surface. It is rusting on the surface because of the activity of gas and dust. This photograph is taken by Hubble Space Telescope in 2002. It is rusting on the surface because of the activity of gas and dust. This photograph is taken by Hubble Space Telescope Jupiter, 319 times heavier than Earth, takes 11.86 years to go around the Sun once, but takes only 10 hours to go around itself. With a tremendous speed, it has dragged the clouds of the atmosphere and created this belt-like structure. Till today, more than 80 moons have been discovered on Jupiter. Next is Saturn, one of the beauties of the solar system. The fantastic ring system takes 29.4 years to go around the Sun once, also has more than 80 satellites. Uranus, yes, with a ring. Neptune, blue in color, covered by a methane-bearing cloud. And our Nande Munne Pluto, till some years back, it was the ninth planet with three of its major moons, Charon, Nix, and Hydra. Mars. For the last 20-25 years, every 3 to 4 months, you open the newspaper, television channels, Mars this, Mars that. Why is Mars so important to the scientists? Why they are spending billions of dollars, billions of rupees to understand Mars? Because they have found this sort of geophysical signatures. As if liquid water has cut through the mountainous region, liquid water will probably mean life. So if even today, the Martian soil as subsoil has some bacteria, virus, parasite. Every year, on an average, few hundred kilograms of rock come scattered from Mars and land onto Earth. If such a rock can bring those bacteria, virus, parasite, you may know what can happen. Within 6 months to 3 years, the whole life form will be totally disrupted, like what has happened in the last 2.5 years. A small entity, coronavirus, has disrupted the whole world. So it is for our safety, for our knowledge, that we should know deeply about Mars. 2008, a spacecraft called Phoenix landed onto Earth. Among a lot of instruments, it had a robotic arm. When it scratched a little bit, it found a white sediment. You see in the inset 3 white peoples after 4 days not to be seen. This is probably the first time human civilization have found the proof of water ice outside the boundary of Earth. And the next picture is more dramatic. It is this wall of a huge crater on Mars. And this is summer. The next picture is winter. And you see in summer, these black finger-like things. Liquid water was found floating on the surface of Mars. So immediately the scientific community realized we have to go deeper and deeper. 2012, in August, Curiosity landed onto Mars. And the first set of pictures it sent is amazing. Dried up riverbeds, as if one day water is to flow through that. Pebbles can occur only when there is a flowing water. So definitely it seems that there was water on Mars. And when everybody, the scientific community in the world, was getting interested in trying to find out what to do next, 15th of August 2012, India's Independence Day, the then Prime Minister declared that India is ready for a mission to Mars. Believe me, my friend, the whole world started as if laughing. They never could believe that the Indian technology is matured enough to send a mission to Mars. Lot of criticisms, lot of ridicule. But believe me, you all know the story. On 5th of November 2013, sitting atop a nose cone of a PSLV X-25 rocket, Mars Orbiter Mission, or Mangalyaan as it was called lovingly, was sent out to space. And on 24th September 2014 at 8:02 a.m., India became the first country in the world, its first attempt, successfully inserted Mangalyaan on a stable orbit around Mars. No country till today would have done it as done it the first attempt. And my friend, that gives you an idea of the tremendous pace of development, research, and other technological advancement that is going on in the country of India. Whatever we see in the newspaper, television channels, nothing is going good, everything is bad, everybody fighting with each other. But believe me, India's science and technology has taken a quantum leap from the days, say 20, 30 years back. See for yourself, one of the highest resolution camera ever built in the world. Picture of Mars taken from a distance of 84,000 kilometers. Two-dimensional pictures are so high resolution that NASA is creating three-dimensional topography out of it. In the coming 1 decade, 10 years, it's an exciting time for ISRO, India, and interested people. Chandrayaan-3, Mangalyaan-2, Lunar Polar Explorer, Gaganyaan, Aditya L1, Shukrayaan, Indian Space Station, one after another. Path-breaking technological advancement. So let us keep our fingers crossed. Saturn, beautiful ring system, around 3.5 lakh kilometer wide, only 100 kilometers in thickness, and amazingly made up of ice crystals and pebbles. How come ice crystals and pebbles are not getting dissipated, keeping the shape and size of a disk of a ring? And the equilibrium going round Saturn is a big question. And this picture takes the cake. This dot is the image of the Earth. So if one day, suppose you have landed on the Saturn's moon or Saturn's ring system, and you meet an alien, there is no alien, but just imagine, you meet an alien and he asks you, who are you? The answer that you have to give, that see me, 780 crores like me, billions of other forms of life, rivers, valleys, hills, mountains, oceans, everything is concentrated in this white dot. Actual image of Earth from the Saturnian ring system. So astrophysics does a lot of things for your ego. From this distance, you have to tell, you see that small dot? I am a micro dot in that dot. That is my importance at the moment I come out of Earth. 1801, Italian astronomer Giuseppe Piazzi discovered a piece of rock 900 kilometers in diameter between the orbit of Mars and Jupiter, named it Ceres. People thought a new planet has been discovered. But within a couple of years, 3 more, Pallas, Vesta, and Juno, each about 500 kilometers in diameter, were discovered in the same region. People realized a new class of object is getting discovered, and they are called asteroids. This picture is from NASA. Here, each green dot is a discovered asteroid. Just imagine all going around the sun. And these red dots are called Apple asteroids. Their orbit cuts the orbit of Earth. That means Earth is going around on its own around the sun. They can come and hit the Earth any point of time. The destruction will be devastating. When can it happen? Anytime. As I'm giving this lecture, it can happen 10 years later, 10 lakh years later. So earlier, people were very scared as asteroids was coming towards you. But only today, 27 September 2022, in the morning, a historic experiment occurred. 11 months back, NASA sent a spacecraft towards 2 binary asteroids. They're not coming towards Earth, but one is going around the other. And today morning, at 4:44 a.m., one of the smaller asteroids, called Dimorphos, was bombarded with the satellite, thereby deflecting it from its orbit. So, if an asteroid is coming towards the Earth, scientists, if they know it earlier, they can send such a mission to deflect the path, to deflect the asteroid from its path of collision with the Earth. Are there 9 planets in the solar system? Starting from 1998, scientists started discovering newer and newer objects, spherical objects, in the outermost periphery of the solar system going around the sun. Funny name, Sedna Quadrant 2004 DW. And in 2003, they discovered this object called 2003 UB313 called Eris nowadays, officially named as Eris. It takes 557 years to go around the sun once, and it is larger than Pluto. So what will you call it? You must call it a planet. So there was a tremendous debate, and ultimately it was decided that from now on, solar system will have 2 objects, 2 types of objects. Classical planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and dwarf planets. So our poor Pluto was demoted to dwarf planethood. The largest asteroid, Ceres, became dwarf planet. The newly discovered object, Eris, became a dwarf planet. In 2015, 2 more dwarf planets have been officially recognized. One is called Haumea, another is called Makemake. If I now go out of the solar system, my friend, true pictures of the sky amazes us. And it makes a lot of people ask me the question, what are you showing? We don't get to see these images in the sky. Do you know why we don't get to see these images? Because human eye has something called perception of vision. Within 1/10 of a second, whatever amount of light enters through our pupil and falls on the retina, the optic nerve immediately takes them to the back of our head to create an image. Our eyes are not like a CCD chip. If our eyes were like a CCD camera, looking in a particular direction in the sky for 10, 20, 15, 30 hours, we'd have seen almost every dot in the sky there is a star. And a huge gas clouds floating around of every color, saturation, hues, everything. Amazing. Are all the stars like sun? Answer is yes and no. Why yes? Because most of the stars are burning hydrogen to helium. Most of them, not all. But stars come with different initial mass, different surface temperature, and different chemical composition. In terms of mass, stars can come in the range of 0.08 to 150 times the mass of sun. What is the mass of sun? 2 followed by 30 zeros, 2 to 10 to the power 30 kilograms. In terms of surface temperature, remember the central temperature is 1.5 crore because the thermonuclear fusion has to go on. But the surface temperature, depending on the size, the chemistry, can vary from 50,000 degrees centigrade to 1800 degrees centigrade. And it was a legendary woman 110 years back at the Harvard Smithsonian Astrophysical Observatory, Mary Jump Cannon. She categorized the stars in a particular fashion, which even after 100 years, science cannot change. According to her, the hottest surface temperature star should be, let us call it the O star, next star B star, A star, F star, G star, F star, M star. Sun with a surface temperature of 5,600 degrees centigrade is a G type of star. Another interesting thing I should mention to you, that trying to do astrophysics in a meaningful way, you have to be tremendously clever and resourceful. Because the only signal that comes from a star is the light, star light. You cannot bring the star to your lab, cut it open, put chemical, test it, smell it, and say, aha, this is this. A temperature, chemical composition, age, evolution, movement, effect on its environment, everything should be told by the image of the star. That's the reason you have to be very clever to become a top-notch astrophysicist. That brings me to the question of life and death of stars. Stars are born from interstellar clouds of gas and dust. In the sky, there are regions where one can see these clouds and also star formation processes. Do you want to see real colors on the sky? Star forming region. Don't mix it with the clouds in the atmosphere that we see. That is the third planet of the solar system and atmosphere. And from one of these clouds, 1,000 solar system can be formed. See for yourself. Amazing picture. 2.5 million pixels in this photograph. Each pixels will give you some information. See, at the top, greenish blue, oxygen 5, oxygen 6. Blue, neutral hydrogen. Yellow, sulfur. Black, iron probably. Green, zinc or molybdenum. And white, titanium. A picture tells a story. See for yourself. Do you know the size? At the top, you see these nodules over here. 1, 2, 3. Do you know the size of each of these nodules? Each nodule inside has a fully formed solar system. My friend, cosmos is throwing a challenge to our human intellect. Try to understand me. Try to decipher me. Only then you can try to answer the deepest question of nature, the deepest, most serious questions of science. If you are born, you have to die. Stars die differently depending upon their initial mass. For example, low mass stars, sun, how will they die? See, sun is burning hydrogen to helium at the center. That's why it is alive. How long? Scientists have done small calculation, have shown sun will be burning hydrogen to helium for another 500 crore years or 5 billion years. After 5 billion years, when all the hydrogen at the core region gets converted to helium, the thermonuclear fusion reaction will stop. Energy production will stop. The radiation pressure outward will stop, but gravity is there. The sun will contract. As it is contracting, in the outer envelope, in the layers, there is still a lot of hydrogen. Because of contraction, the temperature rises slowly to 1.5 crore degrees centigrade, the temperature which is already at the central part. And at that temperature, 4 hydrogen nuclei will fuse together and produce helium. Huge amount of energy will be produced. Gas, when heated up, will expand. Sun will become bigger and bigger and bigger. And do you know how big it will be? It will be called a red giant star and will be touching the orbit of Earth. Yes, my friend. After 500 crore years later, Mercury, Venus, and Earth will go all inside the sun much before that. And what is happening to the central region? The central helium ball, because of cell gravity, will contract. The temperature will slowly rise to 1.5, from 1.5 crore to 10 crore degrees centigrade. And at 10 crore degrees centigrade, three helium nuclei will fuse together and produce a carbon nucleus. Helium to carbon production. Again, huge amount of energy. Again, radiation pressure. The inside will stop. But soon, all helium will get transformed to carbon. Then, since the initial mass of the star was 1 to 8 times the mass of the sun, it is not enough that at that stage to produce more gravitational pressure to increase the temperature at the core to 1,000, 10,000, 10 lakh thousand crore. So, the inner core will be a very hot ball of carbon. For millions of years, it will dissipate away the heat and become brown or black in color and will be called a brown dwarf or a black dwarf. By that time, the outer envelope has become so big, it will create a cloud like structure called planetary nebula. Nebula means cloud. If you don't believe my words, you think I'm talking about sci fi, science fiction. These are true color pictures of planetary nebula. And almost 30 years back, using these objects and these images and the observations, we found out that as the star is becoming bigger, the outer shell, it sort of gives out shells of matter, which produces tremendous amount of shock waves. And we could show just behind the shock wave, in a very elaborate calculation, molecules form, which earlier nobody believed. And almost a vibrant branch of science, astrochemistry, became flourishing like mad. Synthesis of molecules in space and interstellar matter. And these are the molecules on simulation that it could produce in the computer. And 1997, 68 of these 72 molecules were discovered. And you see, most of these molecules are organic molecules. That means they are the precursors of life that is getting produced at the death of a star. Stars whose initial mass is 8 to 25 times the mass of Sun. There, at the center, initially hydrogen to helium. When hydrogen goes to helium, helium to carbon. But since the mass is more this time, the gravitational contraction will be more, the pressure will be more, the temperature will be more, and slowly from carbon to oxygen to silicon to sulfur to neon, one after another, elements will get produced inside the core of the star, and it will ultimately reach iron. Since iron has the highest binding energy, you cannot force two iron nuclei to come together, fuse together, and give rise to a bigger nucleus. So the inside will be looking like a peels of an onion, small layers of hydrogen, helium, carbon, neon, magnesium, and ultimately the iron core. When iron is reached, the thermonuclear fusion has stopped. Outward pressure stopped, and gravity takes over. So, with a tremendous speed and energy, these outer layers start falling towards the iron core. The poor iron fellow has nowhere to go, so it tries to compress itself, but beyond a limit becomes incompressible. And by that time, these outer layers will come and slam onto the iron core, get a kick, recoil, try to come up. Because of this turmoil, there is a sudden implosion, or rather, the outer layers explode away. This explosion is called a supernova explosion, a tremendous exposition of energy, 10 to the power 54 odd per second, whereas the average energy output of sun is 10 to the power 33 odd per second. So 10 to the power 21 times more brighter, more energetic is the supernova explosions. So this is basically a pictorial depiction. At the central region, it becomes like a peels of an onion, and when the instability occurs, it explodes, giving birth to what is known as supernova. At the point of explosion, starting from iron 56 to 94, all the naturally occurring periodic table elements gets produced in a fraction of a second. Since they are produced in a fraction of a second, they cannot be produced in huge quantities. And on Earth, they are called rare earth element. You do not get uranium, polonium, thorium, the amount you get, say, calcium, potassium, zinc, or lead. So, as they are thrown out into space, they get mingled with the interstellar clouds, from where next generation stars will be forming, planets will be going round. And it will be amazed to know that each atom of iron in your bloodstream, each atom of calcium, potassium, sodium, whatever your body is made up of, billions of years, they were only formed inside a star. And in the truest sense, not in a philosophical or metaphysical way, in a very realistic sense, you, me, everything, everybody around are made up of star dust. We are all star children. And that is one of the biggest realization that human mind have realized and started looking into the sky with new enthusiasm, with new excitement. Because if you ask your origin, the origin lies in the stars. So you see, starting from gas cloud, ending into gas cloud, gas to gas. But in between, stars have formed different masses, different chemistry, different reaction. So there is, as if, as I can use this word in Hindi, a khichdi going on continuously, something cooking chemically in the interstellar space. And out of this, a new concept has arrived. When people ask the concept of life in the universe, what is life? How did it originate on Earth? Is there life anywhere else? With billions and billions of stars in our galaxy and billions of galaxies in the universe, it is quite easy to answer, are we alone? No, we are not alone. There are lives in very many places. We have not found it statistically, realistically. But about the question of origin of life on Earth, scientists progressively more and more are now realizing you cannot create life on Earth. So the seeds of life came from space, probably, sitting on a meteorite or a comet, which created destruction at the same time seeded the earth with early pre-biological material of life. From there, with the earth's atmosphere, the climate, the chemistry, the temperature, suddenly life spread. So life originated, or the material for life originated in space. And this has given rise to astrobiology, astrophysics, astrochemistry, astrobiology, astrocomputing, astrostatistics. What do you need for possible future? Astronomy is becoming the most coveted subject of intelligent people, research scholars in the 21st century. And last, since I have around 8 minutes of time, I've been given 1 hour. I started at 3:40. A point-like object. Since a point has no dimension, volume is zero. That means any density is infinite. Mass density, charge density, any density. So any object nearby will feel as if there is a tug, an attractive tug of gravity towards that point. And if they reach that point, which you cannot see, because light also cannot come out of this point, because light is also drawn towards the singularity, they are called black holes. And the understanding of the black hole can be wonderfully realized through the general theory of relativity formulations and related mathematics given by Einstein. G mu nu equal to kappa d mu, the Einstein equation, where, as I mentioned in the very beginning, gravity is considered as a curvature of space-time created by massive objects. In this space-time, if the object is infinitely dense, as if visualize it, it doesn't look so simple, as if it has created a hole in the space-time, singularity. But you see, there is a neck region here of this apparent hole. If something falls beyond that, it cannot come out. And yes, there is a region called event horizon. If any physical object crosses that imaginary boundary of event horizon, they cannot come back again. Even light cannot come out from this singularity region outside, right? And this is the artist's impression that if there are two stars, one star has become a black hole, it will attract material from the normal star, which will try to fall in the black hole, but not straight, because it has to lose its angular momentum. It will create a disk called an accretion disk. Huge amount of X-rays and other radiation will come out of the disk. Though you cannot see the black hole, but the presence of this accretion disk will tell you its presence. And not only in case of stars, in case of massive objects, there can be black holes. And there can be four types: Schwarzschild, Kerr-Newman, Kerr-black hole, and Reisner-Nordstrom. Depending on whether they're static, they're charged, they have a speed with a charge or without a charge. And this is a simulation. You have seen it in a movie also of a accretion disk. You are seeing the first half of the disk. The part of the disk which is behind this is actually getting projected as this sort of arch by what is known as gravitational lensing. When there is a heavy object, light cannot move in a straight line. Because of the curvature of the space-time, light which is following the space-time also bends and creates these sort of imaginary pictures, but not imaginary real, because at the center of our Milky Way, they have now discovered a 4 million solar mass black hole. And the image that you are seeing, we have seen it only this year, the processed image of the accretion disk of this 4 million solar black hole, for which in 2020, Penrose for the theoretical concept and Gaze and Genzel a huge galaxy called M87, they have found a supermassive black hole, billion times the mass of Sun. So black holes are not science fictions now. They have been understood, but not really fully. These black holes are understood from the context of mathematical understanding, but physical issues about the black holes are yet to be answered. So, my friend, when you go to the biggest size of the cosmos, where each light and dawn is a galaxy, and the cosmic wave of galaxies, it is a wonderful feeling. I don't have much time to go into cosmology, but post subscribed theory till now, our universe started from a single